Tonight is March the 28th, 2021. I have something for you tonight I think my audio enthusiasts will find interesting. I gotta keep the kitty cat out of the way though. I built this as a driver for the modulator of my AM transmitter because I wanted a way to control the clipping level right here. And I built it component for component out of the Collins KW-1 transmitter. This is it right here, 12AX7, exactly like this, 6AL5 clipper. For this I had some little adjustable coils out of the clocks that used to be in the old low frequency, but it's certain to be low frequency now. We thought they were high frequency back then. Timing clocks for the communication links of 300 baud, 1200 baud. You remember that kind of stuff? Any of you guys? 2400 baud, 9600 baud. Could it get any faster? Anyway, so it's got a 12AX7, 6AL5, this low pass filter, a 12AU7. And then it goes right here it is extended, and it goes in and drives a couple of 6B4Gs. But I got something really interesting about these 6B4Gs that I think you will like, where I can use either a 5881 or the 6B4Gs. I'll show you the schematic for that. Okay, it does about 10 to 12 watts, just like what it's supposed to. I painted it first with the gray wrinkle, and I said, well, you know, it's going to be exactly the same color as these transformers. So I ended up painting it over with blue, and it seemed like it turned out pretty good. That's why it's got that speckle look to it. What I have on the front is just a standard mic, where the mic is on the tip and not the ring of the 1/4 inch jack. And then the Collins PTT, what that means is the way that Collins radio did their microphones, and you all guys that, well, you think about the Collins, you'll know this. The tip is PTT, push to talk. This is the mic connection, and this is the ground, of course. Well, if you got a mono one of these, and of course the tip, it's going to be the mic connection. So that's why I put in two different jacks here. So I can plug in a regular mic, or I can plug in the Collins PTT. And here's what's under it. Like I said, 12AX, 6AL5, and a 12AU7. I think you've all seen those kind of tubes. It's got some interesting little characteristics underneath that you might enjoy. Notice that I use these types of sockets. They have a particular name and I can't remember at the moment. But instead of using terminal strips, I use them for all of my connections. Now, you know, they're really pretty neat, and I like them, but I'm not sure I'm going to use them all that often. I think it's about to get a kitty sniff here. But when you got them kind of in a corner up against a wall inside the chassis, it becomes a little bit of a chore to deal with them. If they were out in the open, so you could get all the way around them, but I did manage. Here's the low pass filter with that little UTC transformer, like I said, one of those clocks. Power transformer down here. I did not use a choke. I just used a 100 ohm resistor between two of the capacitor. I used a CAN capacitor. I haven't done that in a long time. And then I've got it fixed so I can use a 6L6 or the 6B4G. This is the bias. I use cathode bias. This is a cathode bias for the 5881, and here's the cathode bias for the 6B4G with its little pop between the filaments so that I can adjust the hum to ground. But I've got some really interesting things I got to tell you about the 6B4G that I showed it years ago. But those of you that haven't seen that video might find this interesting about the 6B4Gs. And here's the adjustment for that pot to for the 6B4G. This is the audio output. I always put a ground connection on it. I like ground connectors, the fuse, and of course the that IEC type AC plug. It's a little bit extra trouble to cut that rectangular hole, but then you don't have, you know, a power cord hanging out. So I've got to where I go to the trouble. And like I say, I haven't used cam capacitors in ages. 5V4 there. So let's go ahead and hook it up, and I'll show you what it does. And I think especially the old AMers are going to find it interesting, because I can actually measure it. I'll show you on the oscilloscope what the clipping control actually does. So let me warm it up, and we'll be right back. Okay, before we get too carried away in what this is all about, I got really something that I want to show you here that I think some of you will find pretty interesting. You may not realize it, but the pinout of the 6B4Gs, these are the vintage 6B4Gs right here. Here's another pair of them right here. They're all in beautiful condition. Here's what I do to mark them. See how those have two gold dots on the top? That means that's a matched pair. And these two right here have two yellow dots on the top. That means they're a matched pair. You can see those yellow dots. The gold ones are actually slightly stronger, but these are actually a little bit more balanced, so you know, you can't have everything all the time. These are 5881s, and these are the Jan version of the 6B4G. They're actually stamped on there. See, 6B4G USA. They're actually a repurposed 6AV5, and they work good. The difference is these have directly heated filaments. Very simple triode. The kind of triodes we love. And they're actually on and lit right now. But these, while they do exactly the same thing, have an indirectly heated cathode. And the cathode, it's got the filament going through it just like a 6L6. It's got the heater, the filament, going through it with an indirectly heated cathode, with the cathode tied to one of the pins of the filament, which is 2 and 7. So what you have to do is you can have a hookup similar to this. This might be a little bit crude, but I hope it gets the point across. On both the 6L6, 5881, and 6B4Gs, the pin is on the plate's on pin 3, control grid's on pin 5. And the filaments are on 2 and 7. Now in the 6L6 family of tubes, 6V6, you know, they're all the same as far as the pinout goes. It has a screen on pin 4, and one of the ways to connect the 5881 as a triode is just put a 100 ohm resistor between the screen and the plate. Some people just tie them directly together. And this cathode's on 8. So if you're using cathode bias, which I am, you put your cathode resistor, 350 ohms, shunt with a capacitor, to ground. That's pin 8. Now for the 6V4G, the directly heated filaments, and this could be a 2A3 also. Of course 2A3's got 4 pins, but anyway, you could treat the filament the same way. A lot of people go to great extremes to put DC on the filaments. I have never found it necessary, not one bit. I put a 50 ohm resistor between the pins, and off the wiper, that's where I put this 850 ohm resistor with its shunt capacitor to ground. Now if you're using a genuine old style vintage 1950s style 6B4G, I'll show you here and make sure it's in view of the camera. If you're using one of these types, what you end up having to do is adjust the pot for right in the middle, and that's where you'll get the least amount of hum, and it'll perform perfectly. To me, they always do, but you adjust the pot to the middle. If you use one of these where the cathode is actually tied to one pin, I don't remember which pin it's tied to, but you figure it out really easy, because if you put the potentiometer wiper to one side, you get a lot of hums. You put it to the other side, it works perfectly. I don't remember if it's 2 or 7, but it's too easy to figure out for me to dig into it. So the point being here is, in this little amplifier right here, I can plug in the 6B4Gs, vintage. I can plug in the modern day, if you want to call it that, 1974. That's kind of modern to me, at least. Or I can plug in the 5881s. And the only thing I have to do, let me get this out of the way so I don't bust things. I don't want to break anything. The only thing I have to do is adjust this pot that I was showing you a while ago. Right here. In the middle, for the vintage 6B4Gs, to one side or the other, whichever works the best. For the modern day ones, or you can put it anywhere for the 5881s, because it's actually not being used. Probably put it in the middle. You know how sometimes you can have a hum balance pot, and it'll work better in some places than the others. So that might come in handy to some of you guys that want to build and have, you know, and be able to play with it. So that way you can have your 5881 6L6 type amp, and you can also plug in 6B4Gs, as long as you don't, you know, grossly overdrive the plates of the 6B4G. They can't take quite the plate dissipation. Well, actually, the plate dissipation is pretty high on a 6B4G. But that way you can play with them without having to go into, you know, a rewiring scheme. All you got to do is adjust that potentiometer. So that I hope that helps some of you guys. Okay, now the purpose of all of this, again, is to be able to raise. This is to drive a modulator which runs a pair of 4-125s that push-pull. They run 2,000 volts on a plate. It takes about 2.5 to 3 watts to drive them. But you want to keep your modulation up high, but you always have to watch the negative modulation. You can't drive it more than off. If you drive it more than negative and the carrier gets shut off, then it splatters really bad and you cause a whole lot of interference. But if you start studying it, this little circuit right here, this is the Collins KW-1, and then this low pass filter. If you study this really carefully for the Collins, and then you go look up the Johnson, this is the Johnson Valiant. If you study this circuit again right here, you'll see that they're like 99% the same. So you could build either one. Is one better than the other? Probably not. I mean, it uses 12AX7, 6AL5, uses 6C4, which is just half of a 12AU7. And it goes into another parallel. They got this 12AU7 parallel because they're driving a transformer. And lastly, I think I got one here of a Heathkit Apache. Yeah, it's a little bit different, but you still see that they use a 12AX7 input, so you get a lot of gain. There is no negative feedback in this thing, so the gain is just, it's off the charts kind of. They've got their 6AL5 with a slightly different configuration, and all of these sound very, very good. They're really nice sounding AM transmitters. So that is that. Now, what we want to do here, I want to show you a couple of things. And if there's some old-time AMers out there that have any ideas or better thoughts, then by all means, please let us all know from your experience. But I want to show you what it actually does. Okay, first thing we'll do is just point the camera over here and run it up to some reasonable power level. We're not trying to see how much power we can get out of it, and we're not trying to, you know, absolutely minimize distortion and all that kind of stuff either. So let me turn on a different light. Maybe that light on and that light off. Maybe that'll be a little bit better. But no, I think it's just right here that's really causing. There we go. Now, that's better, isn't it? Well, here's what it looks like on a scope. There's its power in watts. Its distortion is relatively high for a. Let's see, can we see its distortion in the meter here? I don't believe we can, but if we turn this up right here, we can. There, we can see all of it there now. Here's its distortion here, 5.3%. This is all at kilohertz. So we can run the power up by turning the gain. We can run it up to whatever we want. And you can see it starts to flat top pretty bad there, squares off at 10 watts. But actually I want to show you on a different scope here. I'm going to move the camera around here, so bear with me while I bump around so you can see what it looks like on a beautiful old vintage scope. I should also thank my friend back in Atlanta for sending me this this beautiful preamp down here. He sent it to me a few months back. Works great. Got the little New Vista triodes in it. This scope is from probably the late 60s. It's a 535A. Isn't that a pretty thing? Okay. I just want to look at the output on there. Let me turn the lights off again. And, well, that may be a little bit too dark. Just what we can. Oh, that's even worse. It's just really hard to think the way we want. Let's leave it like that. And we'll zoom in just a little bit. I want you to see this. This is kind of important, because I've never seen what it does. And when I start turning up the clipper, I'm going to leave the volume right where it is. That would sound great right there. That's very good audio. But when I start turning up the clipper, watch what happens. First of all, it starts at the bottom. It starts attenuating the bottom. As you can see, the bottom starts pulling up. As you turn it down, it starts turning it into a kind of a smooth square wave. We don't want it to have sharp edges on it, because that creates a lot of harmonics and our ears just don't like it. But that's actually what it does. That's what the clipper, that 6AL5 clipper, does to the audio signal. Now, of course, now the distortion is increased to 23.9%. I can turn around and look at it, which is pretty bad, and even at voice that would sound pretty harsh, I think. But there's something sometimes about a harsh sound, believe it or not, that actually gets through better than a very clean sound. You know, sometimes we want our audio to sound like we're an FM stereo broadcast station, and if the conditions are really, really good between communications doing a QSO, then that's good. But if there's QRM and there's static and there's QSB fading in and out, then sometimes actually a higher pitched, a little bit more distorted type of more contoured audio will get through a whole lot better. So that probably right there, something about it, that level right there, probably is actually more of a better communication link than that. I know that sounds crazy. If you crank it all the way in, well, it just goes away. You can't shut it all the way down to nothing. The power is actually dropping too, considerably. But something about like that is probably about right. It's actually clipping the bottom a little bit more than the top. That doesn't necessarily mean by the time it gets to the modulator it's clipping the bottom more, because it gets inverted many times along the way, and you don't really quite know what it's going to be when it gets there. But that's one thing about it that I don't think I have ever seen a demonstration of, is what the clipping circuit actually does. And what I'm doing is I'm just turning this one right here. It doesn't start doing much until you get to be about 7 or 8, and then it gets really harsh up there. And the last thing I want to show you on this thing is what the voltage is on it. I found that very interesting. I found the voltage, what it does to the voltage on this little 6AL5 clipper, because one side of this pot is at ground and the other side's at 300 volts. So we're varying the voltage on the plates of this little guy right here, and all of the audio is passing through it to the next stage, and of course this stage is driving the output tube. So let me flip it upside down, and I'll document that for future reference in case it might help somebody. Okay, now what I'm going to be showing you here, I'm just going to zoom in on the meter so you can see, but what I'm going to be showing you is what this, whoops, there it is, what this potentiometer right here does is I vary it. This is the clipper control. What it does to the voltage on the plate the 6AL5, and then if you want to know what it does on the other electrodes, then you know you can figure that out. But I found it interesting. Okay, so the meter probe is right here between where pin 2 and 7 are connected together, and watch what it does. Okay, right now the clipping control is turned completely out. So I think for all practical purposes, the diode is transparent. It's just going through it. Okay, as I turn it up, see how the voltage starts going down. So it's doing something to it. Maybe even a little bit more than we could see. So it went down to 54 volts, go up to 44. Keep turning it down. Well, I want you to notice here, I don't know if you can see it, but see it's plus. It's a positive voltage, positive 27.86. And as we keep going down, it finally, still positive 14, 5 volts. It's clipping horribly right there. I can turn around and look at the scope. But at some point it actually goes negative. See, it went negative 1.8 volts. That's its total extreme of minus 2.3 volts. It's actually shut off. There's nothing coming out of it. There's nothing coming out of the amplifier. So a pretty hard clipping level is about right there, about 17 volts. There's no sharp. Here, let me turn around. I'll show you what it looks like that there was 17 volts. Hang on. I know that could make some of you guys dizzy. I'm whizzing this thing around, zoom back out here, and then got to film with the camera here. That's what it looks like with 17 volts. Okay, well, let's look at it this way for a minute. Let's zoom in just a little bit so you can get it pretty good. I know that's really bright. Let me see if I turn the intensity down. Maybe you can see it better like that. That's at 17 volts. Let's see. That's where they completely. Well, I know that's the volume. Sorry. No. That's where they completely out right there. We'll turn it up to about right there. Okay, that's at 83 volts. That's at 61.9. There's 43.9. 42, yeah, 17.99, 18 volts. So it's starting to clip right there. 11.5. So anyway, and like I say, that's all the way. It shuts it off. Good conducting. So whatever that is worth, I don't know. But if you build stuff like I do, and you as we all like to know, we like to have comparisons. Is mine right or wrong? I don't know. It is what it is. And it works. And people say it sounds good. I've had a number of QSOs with it. I'm actually quite pleased with it. Before, what I've been running is a high-end studio type mic into a Behringer preamp. And then that drives a real nice little high-end mono amp I built with the BO13 transformer. It does a beautiful job from 20 to 20 kilohertz at low distortion, and you know, it's a grade 1 class A type hi-fi amp. And then that's what drives the modulator. And people say it sounds fabulous. But I was getting a little bit of what I believe was some RF back into the audio system on 20 meters. I don't have any issue on 40, but I was seeming to get a little bit of RF back into it on 40. So that's why I went to the trouble to build this thing, and it wasn't that much. But you know, I'm getting to where I just, oh my God, it's just getting harder and harder to build. Maybe I'm just getting lazy. There's actually only a few little touches to this. There's a little, you know, grid stopper resistor right here that'll probably help with the RF. Then there's a shunt resistor right here, 47 picofarads off the ground. There's another one right there. But I haven't built onto those little tube sockets that I was showing you earlier. These types of tube sockets, I haven't built onto those things in a long time. and they're really pretty darn neat. But like I say, having up against the color of a chassis is really quite a chore. And there's that. Goes up to the little 6AL5, goes up to the second one, goes that little transformer there on the right. This is just to take the high frequencies off so you don't have any, to eliminate as much as you can of the harshness. And then there's the output tubes, and like I say, the two there's the over in that corner is the bias, cathode bias resistor and bypass capacitor for the 6B4Gs, and the other one's mounted up here on the top. That's a little UTC transformer in the back that I only had one of. I got it at an estate sale here some years ago. So there you go. I hope this helps, and you guys and gals are staying safe and having fun. We're about to come out of this pandemic, it looks like. So God bless you all, and stay safe. Thanks for watching.